Hey guys, this is Professor Janacek, and I want to go over evaluating triple integrals in rectangular coordinates. First off, this setup looks just as you would expect. We've got the integral over a region I'll call D of a function that is in terms of x, y, z, and we're integrating with respect to volume. Now, yes, we could set that up as a limit of a Riemann sum, but more often we're just going to go straight to writing it as an iterated integral. In this case, we can integrate with respect to x, and then with respect to y, and then with respect to z, although there are 6 different orders that we could work this integration. The thing to be aware of with this, notice in this situation, my region of integration D, I have x is being defined from a to b. Notice y is a function of x and z is a function of x and y. This is why I've chosen the order of integration x, y, z. Now, if I wanted to change how I defined those relationships between x, y, and z, then we might want to change that order of integration. Also, if you recall back in double integrals, if I wanted to find the area of the region, I could simply take a double integral over that region R. So again, finding the area of a region, I integrate over that region, and the integrand is just 1. That's also the case here if I want to find the volume of my region D. I simply take the double integral over that region, and notice my integrand is just 1. Let's take a look at an example here. Let's find the volume of the solid in the first octant when the cylinder z is equal to y minus z is equal to sine of y for y between 0 and pi inclusive. When this cylinder is sliced by the planes y equal to x and x equal to 0. All right, you'll notice in this case I don't have a function f. So I am simply looking at finding the volume of that region D. So we're looking at the volume V is the triple integral over D dV. Now, there are a few ways of setting up this integral. I do see that I have y going from 0 to pi, and then x. Notice x goes from 0 up to y. Notice I'm using this right here from 0, and then x also goes up to y. And then my z value would go from 0 up to the sine of y. Again, I have z defined on y. In this situation, I'm integrating with respect to z first, and then with respect to x, and then with respect to y. Now, I will let you know, if you follow this through, you end up having to integrate y times the sine of y dy, which is possible, but it's not just a simple antiderivative. So I am going to not go in this direction. Instead, let's change the order of integration. And by the way, I would have only known this if I had followed this through, which I did. I started this integration, and somewhere in the middle of it, I realized that I end up with having to integrate y sine of y dy, which again, possible, but not necessarily the most straightforward. So I could make this a wee bit simpler if I change the order of integration. Instead, let's take a look. I still like integrating from 0 to the sine of y first, so I'll still integrate with respect to z first. But let's see about swapping the x and the y order. So let's integrate with respect to y and then integrate with respect to x, which means if I look at the y values, y would go from, notice it goes up to pi, but since y is equal to x, it would go from x up to pi. And then the x values go from 0 up to y, but y can go up to pi. So I'm just kind of playing around with the idea that 0 goes from that y goes from 0 to pi and that x goes from 0 to y. That allows me to say that x also goes from 0 to pi, but now y goes from x to pi. I do have to kind of think about where these lines are, where these values are, but I think we are now ready to integrate. That first integration, the integral of dz is just z. We'll evaluate from 0 to the sine of y, which gives us the sine of z minus the sine of 0. Which is sine of y. What am I doing here? The sine of y minus 0. Again, evaluating z goes first the sine of y, and then evaluating z at 0. So we're integrating now just the sine of y, dy dx. All right, integrating with respect to y first gives us negative cosine of y, which we'll evaluate from x to pi. So that would be negative cosine of pi minus negative cosine of x. Which we can simplify, and that gives us an integrand of 1 plus cosine of x. And now we simply integrate with respect to x. X plus the sine of x, evaluate that from 0 to pi. Which looks like that will give us just pi. And there you go. Enjoy.